How to select a motor? There are a few reasons why electric motors are designed to run at 50% to 100% of the rated load and why their efficiency tends to decrease dramatically below about 50% load. One reason is that electric motors have several losses, including copper losses, iron losses, stray losses, and mechanical losses. These losses are all minimized when the motor is running at its rated load. When the motor is running at a lower load, the losses become a larger percentage of the total input power, which reduces the efficiency. Another reason is that the magnetic field inside an electric motor is not perfectly uniform. This causes the motor to produce more torque than it would if the magnetic field were perfectly uniform. However, this also causes the motor to consume more power. The difference between the actual torque produced by the motor and the torque that would be produced if the magnetic field were perfectly uniform is called the torque ripple. Torque ripple is minimized when the motor is running at its rated load. When the motor is running at a lower load, the torque ripple becomes a larger percentage of the total torque, which reduces the efficiency. Finally, electric motors are designed to operate at a certain speed. When the motor is running at a lower load, it will tend to run at a slower speed. This is because the motor is not producing enough torque to overcome the load. The slower speed reduces the efficiency of the motor. For all of these reasons, it is important to operate electric motors at their rated load or as close to their rated load as possible. This will help to maximize the efficiency of the motor and reduce energy costs. Here is a graph that shows how the efficiency of an electric motor changes with load. Graph showing the efficiency of an electric motor changing with load. The efficiency is highest at 75% load and decreases as the load decreases. As you can see from the graph, the efficiency of the motor is highest at 75% load and decreases as the load decreases. This is why it is important to operate electric motors at or near their rated load.